Okay. See, Pravalika and Sahana, listen. In a Hilbert space, the wave function is represented by, or a quantum system is represented by a state vector psi. State vector psi. In a Hilbert space, the quantum mechanical system is represented by using state vector psi. A Hilbert space spanned by position vectors are called this Hilbert space spanned by position vectors. Position vectors are called position space. No need to by heart. Position space. No need to by heart. A space, Hilbert space spanned by position vectors are called position space, and that can be represented by using psi of r or psi of x. Position space can be represented by using psi of r or psi of x. Position space. And the Hilbert space spanned by momentum vectors. Similarly, Hilbert space spanned by momentum vectors. Momentum vectors are called momentum space. Momentum vectors is called momentum space. Here, the momentum space is represented by using psi of p. Psi of p. Now the task is we are going to change psi of x, position space to momentum space, or momentum space to position space. For the transformation, we can use Fourier transformation. Fourier transformation. Now we are going to change the position space to momentum space, or momentum space to position space, by using Fourier transformation. Psi of x to psi of p. Psi of p. This psi of p is the Fourier transform of psi of x. Psi of p is the Fourier transform. Psi of x. Remember, psi of p is the Fourier transform of psi of x. Don't worry, you will get a direct question from this part. Transform psi of p to position space, or psi of x to momentum space. Remember the equation. I will give you the equation. Psi of x to psi of p. Psi of p is the Fourier transform of psi of x. And psi of x, what is psi of x? Psi of x is Fourier inverse transform of psi of p. Psi of x is Fourier inverse transform of psi of p. 1 minute. Okay. Psi of p is the Fourier transform of psi of x, and the psi of x. If psi of p is the Fourier transform of psi of x, then we can say that psi of x is the Fourier inverse transform of psi of p. Now I am going to give you the equation for conversion. Psi of p equal to, please write down the equation. Psi of p is equal to 1 by under root 2 pi h cross integral minus infinity to plus infinity psi of x e power I kx dx.
This is Fourier transform.
1 minute, 1 second. Okay, sorry. Yes, this is Fourier transformation. We are going to transform psi of x to psi of p. Psi of p equal to 1 by under root 2 pi h cross integral minus infinity to infinity psi of x e power minus I kx dx. Minus I kx dx. What is inverse transform? Psi of x equal to 1 by under root 2 pi h cross integral minus infinity to plus infinity psi of p e power I kx dx. Remember these two equations, very important for your CSIR examination. You will get transformation from momentum space to position space.
Should it be IKP dp? Inverse transforms.
Inverse transform. But for converting psi of p to position space to momentum space and momentum space to position space, these two equations are enough.
No, in the second equation, x should not be there. No, p should be there. The right side. dx ikx.
Psi of x equal to
1 by root 2 pi h cross integral minus infinity to infinity psi of p e power ikp dp.
E power, yes. No. Psi of p dx only. See here, exponential is e power ikx, right? Variable is x. Okay, we'll check while doing problem. X only. X is the variable. Exponential e power ikx. In Laplace transformation, e power minus sx. Okay, write down one question. Consider a particle of mass m. Consider a particle of mass m is confined to a region minus a less than or equal to x less than or equal to a, having the wave function psi of x equal to a minus a less than or equal to x less than or equal to a and 0 elsewhere. Find psi of p. Psi of p. Once again, consider a particle of mass m is confined to a region minus a less than or x less than or equal to a, having the wave function psi of x equal to a from minus a to plus a and 0 elsewhere. Find psi of p. What is a? A is normalization constant. First, you should find our wave function is actually a into 1. A. Find normalization constant value. Substitute in the equation, psi of p equation, and find psi of p. What is the value of normalization constant A?
Ma'am, is it 1, ma'am?
1, ma'am. See, psi of x is equal to A. Now we are going to find A value. Integral minus A to plus A, magnitude of psi square dx. A square psi square, sorry, psi square value is A. Integral minus A to A square 1 dx.
0.
Not 0. Normalization constant value is not 0. See here, this is equal to 1. This is the equation for finding normalization constant. Integral minus a to a mod psi square dx equal to 1. Here, wave function value is 1. A into 1, 1. Integrate a square into x minus a2 plus a equal to 1. A square into, substitute upper limit.
1 by root 2a.
Yes. A equal to 1 by root 2a. Don't make mistake while finding normalization constant. Upper limit, substitute upper limit a minus lower limit minus a. A minus a plus a, 2a. A is 2a into a square equal to 1. A equal to 1 by root 2a. Therefore, psi of x, our wave function will be equal to 1 by root 2a. Now we have psi of x value. Substitute in psi of p. Psi of p is equal to 1 by under root 2 pi h cross square integral minus infinity to plus infinity psi of x e power minus ikx dx. Substitute psi of x value here. Not h cross square is not there, right? 1 by 2 pi h cross. H cross square, no h cross square. 1 by root 2a integral minus. Here limit is from minus a to plus a e power minus ikx dx. One by 2 into root h cross pi a e power minus ikx divided by minus ik minus a2 plus a. Minus ik into
sin ka by k root of pi ah.
Yes, yes, very good. Here you will get e power minus ika minus e power ika upper limit and lower limit. Minus minus cancelled. You can write 1 by 2 under root h cross pi a minus, take minus outside. Here you will get e power minus ik, e power plus ika minus e power ika. This 2 and 1 ik you have outside. That 2i take inside the bracket 2i. Here you have 1k, 1 by k, and 2 consider, take inside, and your answer will be 1 by under root h cross pi a into 1 by k into
sin ka.
Yes, sin ka. See, 1 by under root h cross pi a e power ikx minus e power minus ikx divided by 2i. This value equal to e power x minus e power minus e power ix minus e power minus ix by 2i equal to sin x. Therefore, here you can write 1 by k under root h cross pi a sin ka. Sorry, here a. This is the answer. Write down one homework question. Homework. Psi of x equal to a e power minus mu mod x. See, don't neglect a homework question. The homework question, what are the questions I am giving you as homework is from your previous CSIR question paper. Psi of x equal to a e power minus mu mod x. Find psi of t. Find a normalization constant and substitute. Use our Fourier transform equation. Okay. Next, equation of motion. Equation of, see, in classical mechanics, F, force F is equal to ma, that is equal to m dv by dt, or F is equal to dp by dt in classical mechanics. Classical mechanics paper started on. In quantum mechanics, how we can write equation of motion? In quantum mechanics, our physical quantity is physical quantity in quantum mechanics. is our operator, A cap. What is equation of motion? Equation of motion. Rate of change of physical quantity. The rate of change of physical quantity. Now we are going to measure this quantity A. d by dt of expectation A equal to in Dirac notation, A cap is equal to psi A cap psi. Here d by dt of expectation A equal to d by dt of psi A cap psi. Listening up?
Yes, ma'am.
Okay. I'm not giving you the proof. No need of proof. Remember the equation of motion. Equation of motion. D by dt of expectation A is equal to 1 by IH cross average of or expectation of commutator A comma H plus dou A by expectation dou A by dou T. This is called Heisenberg's equation of motion. D by dt of expectation A equal to 1 by IH cross expectation of commutator A comma H. H is our Hamiltonian total energy plus dou A by dou T. Application 1. Conservation of a physical quantity. Conservation of a physical quantity. Remember the formula. D by dt of expectation A. The same equation. See, if A comma H, commutator A comma H equal to 0, that means A and H commute with each other. Dou A by dou T, dou A by dou T equal to 0 implies A cap does not depend on time explicitly. Dou A by dou T equal to 0 implies this operator A cap does not depend on time explicitly. A comma H equal to 0. Dou A by dou T does not depend on Therefore, if a comma h and dou a by dou t are 0, therefore d by dt of expectation a is equal to 0. That means this is constant. This quantity is constant. A cap is constant of motion. Okay, next application. Application 2. First theorem. First theorem. This first theorem connects classical mechanics and quantum mechanics. Classical mechanics and quantum mechanics. Please write down the statement. The variables in classical equation of motion. The variables, first theorem. The variables in classical equation of motion. The variables in classical equation of motion can be replaced by quantum mechanical expectation values. Quantum mechanical expectation values is known as First theorem. Variables in classical equation of motion can be replaced by quantum mechanical expectation values. See, we know that in classical mechanics, dou r by dou t equal to v. V equal to p by m. Dou p by dou t equal to f. F equal to minus del v. From this we can write dou p bar by dou t equal to minus dou v by dou r. Okay, now we are going to find how this first theorem connects quantum mechanics and classical mechanics. See, once you have completed the slide, please let me know. Okay, I am waiting for you to complete. See, we know that d by dt of expectation A is equal to 1 by I h cos expectation A comma h plus dou A by dou t. Then what is d by dt of expectation x? Okay, instead of a we can substitute x 1 by I h cross expectation commutator x comma h plus dou x by dou t. What is this Hamiltonian value? H cap. Not H cap. No, not H cap. Hamiltonian H. Total energy. Total energy H is equal to Px square by 2m plus V of x. Instead of H, substitute this value. Find the commutator relation. Remember this dou x by dou t. This operator x is independent of time. Therefore, this value will be 0. Consider x cap does not depend on time and this term will be 0. Here substitute h value and find the commutator relation. And please tell me finally what you are getting. D by dt of expectation x equal to.
Can you repeat again?
Can you repeat?
Yes, ma'am.
Okay. See, we know the Heisenberg's equation of motion, d by dt of expectation A. This is the equation. Now, we are going to find what is the time rate of change of expectation value of x. Comparing these two equations, here our variable is A. Here x. Instead of A in the equation, you can substitute x. 1 by IH cross expectation commutator x comma h plus dou x by dou t. See, dou A by dou t equal to 0. That is, this function A does not depend on time explicitly. Here also we have x is an operator. Therefore, expectation value of this term also we can consider as 0. This term will be 0. What are the remaining terms? 1 by IH cross expectation x comma h. Substitute h value inside the commutator bracket and find this value. Finally, what you are getting? D by dt of expectation x will be equal to.
I am getting expectation value of P by M.
Expectation Px by M.
Yes, ma'am.
Everybody, please listen. We are going to find expectation. Commutator x comma h. Commutator x comma h. Px square by 2m plus V of x. X comma this function plus x comma this function. X cap comma Px square by 2m plus x comma V of x. See, this V of x is a function of x only. X and V of x. Function of x. Therefore, x comma Vx is 0. This relation 1 by 2m x comma Px IH cross 2Px. You should remember how to solve commutator bracket. Otherwise, it will be difficult. 2 cancelled. And if while we substituting in the equation 1 by IH cross expectation x comma h value is Px by m into IH cross. Cancel. D by dt of expectation x equal to expectation Px by m. Any doubt? Sahana, Pravalika, Deepika?
No, ma'am.
No, ma'am.
See, after the class, please share homework question answers. Okay. I got answers from only one student. Others, please try to share your answers. Not for me, for you. Try to solve a lot of questions. Okay. D by dt of expectation x equal to expectation px by m. This equation is having any similarity with the classical mechanics equation?
Velocity.
Yes. Similarly, now we are going to find what is that you should find d by dt of expectation px. Please find d by dt of expectation px. There also you can consider px does not depend on time.
Minus dy by dx.
Minus
dy by dx.
Minus dou v by dou x expectation. Nothing. Px comma px square by 2m plus v of x. Px comma px 0. The remaining term px comma v of x. That is d by one minute. That means not working. I think it is clear for you. D by dt of expectation px. Getting a minus expectation dou v by dou x. Okay. D by dt of expectation px equal to 1 by ih cross expectation px comma h. Px comma h. Second term will be 0. Now we are going to calculate this commutative relation. Px comma px square by 2m plus v of x. Px comma px 0. What is remaining? Px comma v of x 1 by ih cross px comma vx 1 by ih cross px comma x. Px comma v of x is a function of x. Px comma x minus ih cross derivative of v of x dou v by dou x. ih cross cancel minus dou v by dou x. Therefore, d by dt of expectation x equal to expectation px by m, d by dt of expectation px equal to minus dou v by dou x expectation. In 3D, d by dt of expectation p equal to minus
del v.
This reduction of quantum mechanical dynamics to the classical trajectories. Please write down this reduction of quantum mechanical dynamics. This reduction of quantum mechanical dynamics to the classical trajectories. To the classical trajectories is known as first theorem. No need to by heart, understand the concept. We can convert this quantum mechanical dynamics to classical mechanics trajectories and write down it only holds for expectation values. In quantum mechanics, it holds only for expectation values. Or average value of the measurement. Expectation value means average value of the measurement. Completed. Now we can do one problem. Okay. Consider a particle of mass m. Consider a particle of mass m moving in harmonic potential consider a particle of mass m moving in harmonic potential v of x equal to half kx square. Find d by dt of expectation x, d by dt of expectation x square, d square by dt square, d by dt of expectation x, d by dt of expectation px, d square by dt square expectation x, and d square by dt square expectation px. See, what is our Hamiltonian? Px square by 2m plus v of x. What is v of x here? Substitute px square by 2m plus half kx square. I think the question is clear for you. First, find d by dt of expectation x. Use the formula and substitute. We know that d by dt of expectation x is px by m. Next, d by dt of px is minus expectation dou v by dou x. D by dt of expectation x equal to px by m. This is the answer. What about second one? D by dt of expectation px minus dou v by dou x. What is dou v by dou x value? I think you are following the class.
Kx.
Yes. Only kx, huh?
Minus kx, no?
Yes, minus kx equal to minus k expectation x. This is our d by dt of expectation px. Sharavana Kumar, new admission, huh? D by dt of expectation x. D square by dt of expectation x square. Doing nothing. Simply write down like this. D by dt of d by dt expectation x.
Minus k by m expectation of x.
Yes, very good. Minus k by m. Minus k by m expectation x. D by dt of expectation x. Substitute this value. D by dt of expectation x is px by m. Substitute px value and differentiate. Dt of expectation x is px by m. D by dt of, what is our px value? Minus k expectation x by m. Similarly, d square by dt square of expectation px.
Minus k by m expectation.
Yes, minus k by m expectation px. Very good. Minus k by m expectation px. If you follow my classes, then you can easily score complete mark from the quantum mechanics part. I am not leaving any topic from this part. Completely I am doing. You should study thoroughly.
Mom, can you explain the last one? No? D square by dt square.
Sure. See, d square by dt square of expectation px. This we can write d by dt into d by dt of expectation px. I think this much is clear. Okay. d by dt of, we know the value of d by dt of expectation px. What is d by dt of expectation px? Minus k into expectation x. What is d by dt of expectation x?
Px by m.
Yes. d by dt of expectation x is minus k expectation px by m. See, in the last class, I have given one homework question from commutator operator algebra part. What is the relation between gamma and beta? Find the relation between gamma and beta. Any of you have completed those questions? Those questions, including the remaining questions. Harmonic oscillator problem and hydrogen atom question. If you have missed that question, please try to find answer and send me in my WhatsApp number. That was previous CSIR question. Don't neglect. Write down one homework question from this part. H Hamiltonian is equal to Px square by 2m plus 1 by 2 m omega square x square plus v naught x cube. Find d by dt of expectation x, d by dt of expectation px. Here, potential value equal to v of x equal to, in this question, v of x equal to, Deepika, v of x equal to in this question. This is the kinetic energy and this is our potential energy. V of x equal to half m omega square x square plus v naught x cube. Don't leave this term. The whole term include v of x. Potential energy term. Find d by dt of expectation x, d by dt of expectation px. Okay, take a 5 minutes break and 5 or 6 minutes and join at 5. Okay. Hello, take 5 minutes break.
Yes, ma'am.
Okay, ma'am.
Ma'am?
Yes, please tell me.
Ma'am, the hydrogen atom homework question, I did not get it, ma'am.
Hydrogen atom question, huh?
Yes, ma'am. Can you repeat the question, ma'am?
Yes. Please write down the question. Let psi NLM. Let psi NLM is the basis state of an electron. Is the basis state of an electron in the hydrogen atom. With energy En is equal to minus 13.6 electron volt by n square. Remember, this is the nth state energy of hydrogen atom. En equal to minus 13.6 electron volt by n square. The wave function of the system is given by the wave function of the system is given by find average energy. Find average energy.
Ma'am, in this wave function, the last two terms are degenerate, ma'am. No, ma'am.
Last two states are degenerate.
They have same n value.
Same n value. Last two states are.
Psi 211 and psi 2.
Okay. Sorry. NLM. Here n value. N value should be different.
Ma'am, for the gamma beta problem.
Yes. Good answer.
Yes, ma'am. Gamma is equal to 2 beta.
Yes. Gamma equal to 2 beta. Very good. And in this problem, see, here you can consider n value equal to 1. Here n equal to 2. And here n equal to 3. 3, 1, 0. Consider like that. Because we are finding P1, P2 and P3 corresponding to 3 wave function. 3 bases, not wave function, basis. P1 for psi 1, P2 for psi 2, P3 for psi 3. So simply you can consider P1, P2 and P3. No need to worry about this basis, NLM value. Yes.
In this Heisenberg equation of motion, why is the expectation of dou A by dou T equal to 0? Is that 0 for everything?
Actually, why we are considering like that means we are measuring average value, right? Average value of operator. This must be independent of time. Consider like that. Always you should consider dou by dou T of, sorry, dou by dou T of operator value. A cap value should be 0. A cap is independent of time.
Ma'am,
Ah.
for the harmonic potential question, ma'am, homework question. I'm getting answer as 5/4 h cross omega. Is it correct, ma'am?
5/4 h cross omega. Yes, very good. 5/4 h
Okay.
cross omega. Now you people are doing homework question, huh?
No, ma'am, I already did that. Hydrogen atom alone, I did not do.
Okay. Anytime you can solve the homework question, but you should understand how to solve the problem. Okay, that commutator relation question, gamma equal to 2 beta. This is the answer. Relation between gamma and beta.
Ma'am, can I ask a doubt?
Yes, sure.
Ma'am, what is the Poisson bracket of XP, ma'am?
Poisson bracket of XP, huh?
Yes, ma'am.
There is some relation between commutator bracket and the Poisson bracket. I think it is x comma p by IH cross up. I forgot. Any of you know the answer? There is some relation between this commutator bracket. Sorry,
This is only relation, ma'am. Correct, ma'am.
Okay. Therefore, Poisson bracket x comma p equal to
1.
IH. Yes, 1. Don't worry, Poisson bracket you will study in detail in classical mechanics. Classical mechanics is also interesting. Okay, now I think we can discuss about uncertainty principle. Uncertainty principle. Uncertainty principle. What is the RMS deviation of a physical quantity? RMS deviation of a physical quantity, delta A, from its mean. How to find delta A? Root of
Expectation of A square minus expectation of A the whole square.
Expectation A whole square. Very, very important. Please remember. Now I am going to give you an uncertainty relation. If delta A and delta B are the uncertainty in the measurement of if delta A and delta B are the uncertainty in the measurement of A and B. Now remember the relation delta A into delta B greater than or equal to commutator A comma B expectation divided by 2i. This is the uncertainty relation. Delta A into delta B greater than or equal to expectation of commutator A comma B divided by 2i. Or this relation we can write delta A into delta B greater than or equal to magnitude of expectation of commutator A comma B. If we consider magnitude, no need to consider I in the denominator. Magnitude of I is 1. Suppose commutator A comma B equal to 0. That is AB equal to BA. Commutator A comma B equal to 0 implies delta A into delta B greater than or equal to 0. Delta A into delta B equal to 0 implies we can measure. Delta A into delta B equal to 0 means no uncertainty. No uncertainty. We can measure A and B directly or accurately. A and B accurately. If delta A equal to delta B equal to 0 means there is no uncertainty, we can measure A and B accurately. Okay, suppose A cap psi equal to A psi and B cap psi equal to B psi. A and B have assume that A and B have same eigenvectors. Now, what is A comma B into psi? This can be written as AB minus BA into psi. AB psi minus BA psi. Substitute. What is A psi? A psi equal to
A psi.
Small a psi.
Yes, small a psi. Here we substitute A psi here, A cap psi equal to A psi B minus here B psi, A cap B psi. Okay. Now what is this B psi? BA psi minus here A psi, AB psi. No need to by heart. I am going to prove one definition. BA psi minus AB psi. Please note A and B have same eigenvectors. That means A and B are equal. Therefore, BA psi minus AB psi equal to 0. So, commutator A comma B into psi equal to 0. No need to remember this. I am giving you one note. Please write down. Only when A and B have okay, first you finish this slide. This is for writing one proof. Only when A and B have common set of eigenvectors. A and B have common set of eigenvectors. we can measure them simultaneously. We can measure them simultaneously. Only when A and B have common set of eigenvectors we can measure them simultaneously, or we can say that the physical quantities are said to be compatible. How the uncertainty value equal to 0? Delta A into delta B greater than or equal to A comma B by 2. AB equal to 0. Uncertainty is 0. If A and B, the operator A and B share all the eigenvectors same, A and B have same eigenvectors, then the product of this uncertainty is 0. That is the thing. Okay, next application. Task. I am going to give you one task. Psi is given. Find delta x into delta px. Psi is given. Find delta x into delta px. The wave function given is equal to psi of x equal to a e power minus half alpha square x square. I think you are familiar with this wave function. Wave function of
Linear harmonic.
Yes, this is the wave function of linear harmonic oscillator. Then please tell me what is A?
Root alpha by root pi.
Alpha by root pi all power 1 by 2. Hello, could you remember the formula? 2 by, this is an example for Gaussian wave function. Psi of x proportional to e power minus ax square. Gaussian wave function. For a Gaussian wave function, the normalization constant equal to 2 by pi into Samuel, 2 by pi into coefficient of x square all power Pravalinga all power
1 by
1 by 4. If you remember this formula for only for Gaussian wave function, no need to find normalization constant. Directly use this formula and write out normalization constant. Following see if you can't follow, please tell me. I am ready to explain. Okay, now we know the value of psi of x. Psi of x is equal to alpha by root pi all power 1 by 2 into e power minus half alpha square x square. Okay, now we are going to find delta x into delta px. For that, first you should find
Expectation value of x, expectation value of x square, expectation value of p, expectation value of px square.
Okay, then please find. And finally, what you are getting, please tell me your final answer. Take your time and slowly do the integration. I am ready to wait for you. Don't worry. Yes.
Why we should find expectation of x square, px and px square?
See, we are going to find delta x and delta px, right? Delta x equal to under root of expectation x square minus expectation x the whole square. What is delta px? Under root.
Why can't we use the formula mod of expectation commutation of x px by 2?
Which relation?
Del a dot del b is greater than or equal to expectation of commutation of a comma b by 2i. That relation.
That relation. Okay, try to find.
H cross by 2.
Yes, h cross by 2. Okay, that is fine. Delta x into delta px equal to h cross by 2. Okay, you can use that formula. Finally, you should get that answer. Delta x into delta px equal to h cross by 2.
Ma'am, greater than or equal to h cross by 2.
Greater than or equal to. Okay, please correct it. Greater than or equal to h cross by 2. And please write down for a Gaussian wave function. For a Gaussian wave function, psi proportional to e power minus ax square. One minute. Again, pen is not working. Okay, please try to solve homework question. Let me change the battery. Try to solve homework questions. Hello, doing huh? Okay, please listen. See, we got delta x into delta px greater than or equal to h cross by 2. Please write down for a Gaussian wave function. What do you mean by Gaussian wave function? Psi proportional to e power minus ax square. Okay, for a Gaussian wave function, that is psi proportional to e power minus ax square. The uncertainty relation is always, see, in your examination you are getting a Gaussian wave function and they are asking you to find delta x into delta px. No need to calculate. Directly you can write for a Gaussian wave function delta x into delta px is greater than or equal to h cross by 2. Anyway, you finished homework questions, right? Please tell me your answers. Not completed. Huh? No response. Okay, write down one question. Homework question. Homework question. Again, homework. Psi is equal to root 15 divided by 4a power 5 by 2 a square minus x square. Psi equal to root 15 by 4 a power 5 by 2 a square minus x square minus a less than or equal to x less than or equal to a. Find delta x into delta px.
Ma'am, for the first one, is the answer 2 mu root mu by root 2 pi h cross into mu square plus k square.
Repeat.
2 mu root mu by root of 2 pi h cross into mu square plus k square.
Mu square plus?
Into, no ma'am, divided by. That's in the denominator.
What divided by?
Mu square plus k square.
Mu square plus k square. I think a correct answer. I don't have the solution right now. Let me do once. Root 2 root mu by 1 by mu square plus k square. Okay.
2 mu root mu.
Oh, mu root mu. 2 mu root mu. Okay.
Yes, ma'am.
Any other answers? Okay, I will check after the class. I don't have solution right now. If I will explain that in the class, it will take too much of time. See, for this question, again, it is not working. See, for finding expectation px, you can use this formula. See, m d by dt of expectation x. Okay. Suppose if you are considering of harmonic oscillator problem, psi of x equal to alpha by root pi all power 1 by 2 e power minus half alpha square x square. Okay. In this question, if you are finding expectation x, what is the value of expectation x for a linear harmonic oscillator?
0, ma'am.
0. So, while finding expectation px, no need to differentiate. See, what is the operator of px? Minus IH cross dou by dou x, that you should substitute inside the integral and find expectation px. But now we know expectation px equal to m into d by dt of expectation x. Therefore, here for a linear harmonic oscillator, what is the value of expectation px? 0. Okay. Directly you can write. See, in the Dirac delta potential part, I missed one topic, Dirac delta potential. In that, I have missed one topic. Now I am going to explain that nothing, only a small change. Please write down. A particle is moving in a Dirac delta potential. A particle in a Dirac delta potential. A particle moving in a Dirac delta potential. V of x equal to minus V naught delta of x. Its wave function will be, for a particle moving in a Dirac delta potential, its wave function will be psi of x equal to root k e power minus k mod x. In your examination, you will get question from this part. Consider a particle is moving in a Dirac delta potential. Find delta x or delta px or uncertainty relation. You will get those kind of question. That time you should remember, for a Dirac delta potential, this is the wave function value. Remember, value of k. K is equal to m alpha by m alpha by h cross square. And remember, we know that E is equal to P square by 2m. E equal to P square by 2m. P square equal to 2me. What is P square? H cross square, K square equal to 2me. P is equal to H cross K. E is equal to H cross omega. Don't forget, P equal to H cross K, E equal to H cross omega. Instead of P square, substitute H cross square, K square. Therefore, K square equal to 2me by H cross square. Remember these values. K square equal to 2me by H cross square. Or you can equate K square value. K square equal to 2me by H cross square and m square alpha square h cross power 4 equal to 2me by h cross square. From this, E is equal to m alpha square divided by 2h cross square. Nothing. Please remember k value. According to the question, you can rearrange the values. Okay, then write down one question. Consider a particle. Completed, huh? I think this slide is completed. Very important. And this is also completed. Consider a particle moving in a potential. Consider a particle moving in a potential V of x equal to minus alpha delta of x. Find the uncertainty in the position of the particle. Find uncertainty in the position of the particle. Uncertainty in position, that is delta x. From the question, we can understand the potential is Dirac delta potential. Therefore, you can consider psi of x. See, in the question, they won't mention psi of x value. You should remember it is root k e power minus k mod x. K equal to m alpha by h cross square. Please remember. Okay, now find delta x. Sahana, expectation x equal to? Hello, expectation x. Similar to our previous expectation value, expectation x equal to only change psi of x. Square this term, k integral minus infinity to plus infinity hello, expectation x into e power minus 2k mod x dx. Samuel, what is expectation x now?
0, ma'am.
0. How? Even limit and odd function. Even limit and odd function. Now find expectation x square. Hello, minus infinity to plus infinity. Even limit. Odd function to even function. Odd into even. 0. Expectation x square equal to k integral minus infinity to plus infinity x square e power minus 2k mod x. For an even function, instead of minus infinity, x square is an even function and this exponential is also an even function. Therefore, you can change the limit. 2 into k integral 0 to infinity x square e power minus 2k mod x dx. Zero to infinity. Therefore, no need to write this mod x. E power minus 2k x. Pravalika, how to solve this integral?
Ma'am, UDV method.
Any other solution? Hello,
We have
everybody.
to differentiate.
For everybody, please go through standard integration formula. Integral 0 to infinity x power n e power minus ax dx equal to integral x 0 to infinity x power n e power
N factorial by a power n plus 1.
n factorial divided by a power n plus 1. Very good. Please use the standard integration formula here and find what is expectation x square. In the first quantum mechanics class, I have explained the standard integration formula.
Ma'am, is the uncertainty 2 by k power 5 by 4?
2
by k power 5 by 4.
2 by okay, let me do. Here we are going to integrate expectation x square equal to 2k integral 0 to infinity x square e power minus 2kx dx. This equation is similar to integral 0 to infinity x power n e power minus ax dx equal to n factorial by a power n plus 1. Here, what is the value of n? N value is 2. Therefore, 2k into n value is 2. 2 factorial divided by what is a?
Okay.
2k whole power 3. 2k, 1 2k get cancelled and here we will have 2 square k square, 1 2 2 cancelled, expectation x square equal to
1 by 2k square.
1 by 2k square. Okay. Now find delta x. Delta x equal to root of expectation x square minus expectation x the whole square. Expectation x whole square is 0. Root of expectation x square 1 by 2k square. Answer is 1 by root 2k. If you want, sometimes in the question, instead of k, they will write k equal to m alpha by h cross square. That you should change according to the option. Okay. If you are not seeing this answer in the option, please replace k. Then you will get the answer. If you try to apply this integration formula here, it will be difficult. That's why I am telling you to remember standard integration formula. Okay, let me explain 2D box. One more topic, 2D box. Completed? Okay, please write down 2D box. Now we are going to find degeneracy of a 2D box. Degeneracy. Degeneracy of a 2D box. What do we mean by degeneracy?
Different states but same energy.
Different state with same energy. For a 2D box, I am going to write down the wave function psi of xy equal to, for a 2D box, two coordinates x and y. Psi of xy equal to root of 2 by L sine nx pi x by L into root of 2 by L sine ny pi y by L. For 1D box, directly we can write root 2 by L sine n pi x by L. But for 2D, remember nx and ny. What is energy? Energy of 2D box, energy equal to pi square h cross square by 2 ml square into nx square plus ny square. Any doubt? See, no need to write Lx and Ly. Length is same. No need to write Lx and Ly. Lx equal to Ly equal to L. But in some questions, they will mention what is the difference between Lx and Ly. In such cases, you should consider that too in the equation. Now we are going to find the degeneracy of 2D box. See, if the Lx and Ly values are different, then you should write like this. If Lx, Ly values are different, then you should write E is equal to pi square h cross square by 2m into nx square by Lx plus ny square by Ly. Here in our question, Lx equal to Ly equal to L. Therefore, E equal to pi square h cross square by 2ml square into nx square plus ny square. Or we can write this as nx square plus ny square into E1. Okay, now we can find degeneracy of a 2D box. Nx values are for 1D box, n values are 1, 2, 3, etc. Similarly, ny values are 1, 2, 3, etc. Now I am going to find degeneracy. Degeneracy in this box, nx plus ny. Here, nx comma ny values. Next, E equal to nx square plus ny square into E1. E1. Increasing order, psi nx ny, psi nx ny. nx and y, nx plus ny value starting from minimum value. Hello, nx plus ny minimum value
2.
Nx value 1, ny 1, 1, 1, 2. Energy, your energy equal to nx square plus ny square 2e1. Now this column keep it as it is. No need to write anything. Here psi nx and y. Psi 1 1. Clear? Next possibility nx plus ny is 3. 1, 2 is possible. 2, 1 possible. Right? For 1, 2 and 2, 1 find energy. For 1, 2 energy equal to. For 2, 1 energy equal to. Hello, E value here.
5.
5e, 5e. Here psi 1, 2, psi 2, 1. Okay. Next 4. What are the possibility? 1, 3, 3, 1, 2, 2. Please find the corresponding energies. And similarly for 5. 1, 4, 4, 1, 3, 2, 2, 3. Find the corresponding energies. Here wave function for this psi 1, 3, psi 3, 1, psi 2, 2. Next, psi 1, 4, psi 4, 1, psi 3, 2, psi 2, 3. Here for nx plus ny equal to 4, what are the possible energies?
10e, 10, 80.
10e, 10e and 80. For 5, E1. Okay, if you want, you can write. Actually, we need the increasing order of energy. 1, 4, 4, 1, 2, 3 and 3, 2. Samuel, possible energies?
17E1, 17E1, 13E1 and 13E1.
17, 17, 13 and 13. Okay. Now you can write increasing order of energy. Increasing order 2E1. After that 5E1, 8E1, 10E1, 13E1, 17E1. Okay, increasing order of energy. Now we are going to write degeneracy. Only one state is having energy 2E1. Therefore, 1, 5E for 2 states, 2, 10, 8 for 1 state, and 10 for 2 states, 13, 2, 17, 2. Hello, any doubt?
Ma'am, for 10 it's 2. Ma'am.
10E it's 2. 2E 1, 5E 2, 8E 1, 10 2, 13 2, 17 2.
Okay.
In between 8 is there. Hello.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, then you can write degeneracy of 2D box. Degeneracy of 2D box. 2D box equal to 1, 2, 1, 2, 2, 2. If you want for higher order, you can find, but no need. At least remember these values. At least remember these values. This is the degeneracy of 2D box. You will get one word question. 1, 2, 1, 2, 2, 2. Can you find degeneracy for 3D box? 3D box. Okay, you do it as a homework. Just try. If you're not getting, no problem. We'll discuss in the next class. If you have time, please try for a 3D box. What is the difference? Energy is equal to nx square plus ny square plus nz square into I square h cross square by 2ml square, or E equal to nx square plus ny square plus nz square into E1. Here I am considering L. That means Lx equal to Ly equal to Lz equal to L. Nx values are 1, 2, 3, etc. Ny 1, 2, 3, etc. Nz 1, 2, 3, etc. Write down possible values for Nx, Ny, and Nz. Find degeneracy. For 3D box, you will get different value. See, you will get direct question. Degeneracy of 2D box. No need to calculate. Remember this one. 1, 2, 1, 2, 2, 2. Doing, huh? Okay, then do. We have one more minute. Okay, do it as a homework. If you want, you can give We'll continue in the next class. Okay, please wait. When I can conduct quantum mechanics test, discuss and let me know. I think tomorrow you will have 3 or 4 hours classes. What about Monday?
Yes, ma'am.
If possible or not, anyway, Monday at 6 o'clock, I will share the question paper. If you have any class or any work, don't worry. When you have time, please try to solve and send me the answers. If you don't have classes, then within 1.5 hours, please submit the answers. 6 to 7:30 exam timing, Monday 6 p.m. to 7:30 p.m. I don't know whether they will schedule class or not. If you don't have classes, please try to attend the exam. Okay, this you can do it as a homework. Now you can leave. What is the time now? Okay, 6 o'clock is. Okay, then, or if you want, I can give you one homework question. I think our next class will be maybe on Thursday. You have time till Thursday. Okay, don't worry. Yes.
For degeneracy of 3D box, how many values we should find?
How many? 3, 4, 5. At least try to obtain values for 3, 4, and 5. Nx plus ny plus nz equal to 3, 4, and 5. Okay. The values. 3D box degeneracy values are 1. Any of you have answers?
133.
1, 3, 3, 3, 1, 6, 3. Please remember. Try to obtain at least 4 values. 1, 3, 3, 3, 1, 6, 3. Okay, I think already you have a lot of homework. Next, one more question is there regarding this degeneracy. That question I will give you in the next class. Okay, now you can leave. Thank you so much, everybody. Deepika, Pravalika, Sahana, and Samuel.
Thank you, ma'am.
Thank you, ma'am.
Please
Thank you,
share homework question answers, okay?
Okay.
Yes.
Okay, then. Please ready to attend exam on Monday. See, Monday to Friday, I am completely free. If you have any doubt, you can share in the in my WhatsApp. Any previous CSIR question, anything. Okay, then. Thank you so much.
Thank you.